Hello everyone. So today we are delving into how thermodynamic principles are crucial in the design and function of watches. We are from section 3. We will explore specific thermodynamic aspects that influence the performance and efficiency of timepieces. Let's go. The objective of our presentation today are, firstly, to understand the working principle of thermodynamics, and secondly, to discuss the importance of theory of thermodynamics in each phase of real-life applications. These are our group members. From left, we have Daniel Fitri. In the middle, we have Aisha Dalila, and on the right side, we have Nun Karina. The contents of our presentation for today are: first, we have introduction. Second, how does it function? Third, process involved. Fourth, the cycle analysis. Fifth, the law of the thermodynamic involved. Sixth, we have efficiency and performance. Seventh, suggestion to improve. Eighth, conclusion. And lastly, we have references. So, without wasting our time, let us jump into our introduction for today. Thermodynamic watches, also known as thermoelectric watches, are innovative timepieces that generate power by converting temperature differences between the wearer's skin and the surrounding environment into electricity using the Seebeck effect. This phenomenon involves a thermoelectric generator embedded in the watch that creates voltage from the temperature gradient. The generated electrical energy is stored in a rechargeable battery or capacitor, which powers the watch function. So let us see how does it function. First, we have temperature difference establishment. The step is the watch is worn on the wrist. The function is this creates a temperature difference between the warm skin where the watch is in contact and the cooler ambient environment. Second, we have heat absorption. Step, the side of the watch is in contact with the skin absorbs body heat. The function is the thermoelectric material inside the watch begin to experience a temperature gradient. Third, we have thermoelectric generator activation. The step is the thermoelectric generator inside the watch, which consists of a thermoelectric material, is activated by the temperature difference. The function, the heat flows from the hot side, which is the skin side, to the cold side, which is the outer side, initiating the Seebeck effect. Fourth, we have Seebeck effect initiation. The step, the temperature difference across the thermoelectric material causes electrons or holes to move from the hot side to the cold side. The function, this movement of charge carriers generates an electric voltage across the material. Fifth, we have electricity generation. Step, the thermoelectric generator converts the temperature gradient into electrical energy. The function, this will be generate voltage drives an electrical current within the watch. Sixth, we have power storage. The step, the generated electrical energy is stored in a small rechargeable battery or capacitor inside the watch. The function, this storage ensures that the watch has a steady supply of power even if the temperature gradient varies. Seventh, we have power management. The step is the watch power management system regulates the voltage and current from the battery or capacitor. The function, this system ensures efficient and stable operation of the watch components such as the timekeeping mechanism. 8. We have continuous operation. The step, the watch uses the stored electrical energy to power its function, and the function is, as long as the temperature difference is maintained, the watch continuously generates and stores energy, enabling it to function without external battery replacement.
There were few processes involved in this thermic watch. Firstly, thermoelectric effect, specifically Seebeck effect. Seebeck effect is when two different conductive materials, thermoelectric materials, are joined at two junctions, and there is a temperature difference between these junctions. A voltage and electric potential is generated. This voltage can drive an electric current in a closed circuit. Secondly is thermoelectric materials. First, high Seebeck coefficient to generate a significant voltage for a given temperature difference. Secondly, low thermal conductivity to maintain a temperature gradient across the material. And lastly, high electrical conductivity to allow the generated current to flow with minimal resistance. The third process involved in this thermic wash is heat source and heat sink. Heat source is when the wearer's body heat, typically around 37 degrees C, which was 98.6 degrees Fahrenheit. Heat sink is when the ambient air temperature, which is usually lower than body temperature. Next is thermoelectric generator, which was TEG. The thermoelectric generator is the central component of the thermic watch. An array of thermocouples composed of thermoelectric materials make up the TEG. The TEG produces a voltage in the presence of a temperature differential. Thermocouples, which was pair of N-type and P-type semiconductors connected electrically in series and thermally in parallel. The voltage generated by each pair adds up, providing a usable output. The fifth process is power management circuit. The voltage and current generated by the TEG are typically low and need to be managed effectively to power the watch. It can be managed by boost converter. Step up the low voltage from the TEG to a higher usable level. Secondly, energy storage. Excess energy can be stored in a small rechargeable battery or capacitor to ensure the watch runs smoothly even when the temperature difference is minimal. Lastly is regulation. Ensure a stable power supply to watch movement and other electronic components. Lastly is heat dissipation. Efficient heat dissipation is crucial to maintaining a temperature gradient across the TEG. Watch design. The back of the watch, in contact with the skin, is designed to absorb heat efficiently, while the front or sides may have heat sinks to dissipate heat to the ambient air. Thermal insulation. Insulating materials may be used to prevent heat from the body from escaping directly to the air without passing through the TEG. This was thermodynamic cycle in thermic watch. Firstly, heat absorption for the body. Secondly, thermoelectric conversion. Thirdly, energy utilization, watch movement. And fourthly, heat dissipation to the environment. Heat absorption from the body. This process is the watch absorbs heat from the wearer's skin. In thermodynamics, this can be considered a heat transfer process where heat Q in is absorbed by the thermoelectric generator. The equation is Q in equal to HA times T body minus T junction. We move to the second step, which was thermoelectric conversion. This is the process when TEG converts the absorbed heat into electrical energy via the Seebeck effect. In thermodynamics, this process can be analyzed using the first law of thermodynamics, which is in the case state that the heat input is partly converted to electrical energy and partly lost as heat. The efficiency of the TEG is determined by the materials and the temperature difference. The efficiency of TEG is equal to P electrical, which was electrical power generated over Q in. The third step is energy utilization, which was watch movement. This process is the electrical energy generated is used to power the watch movement. In thermodynamics, this involved the conversion of electrical energy into mechanical work to move the watch hand and maintaining the timekeeping function. The power management circuit boosts and regulates the voltage to ensure consistent operation. The equation of this watch movement is P watch equal to I watch time V watch. The last step in this cycle is heat dissipation to the environment. This process is the remaining heat is dissipated to the environment to maintain the temperature gradient across the TEG. In thermodynamics, this can be considered as the heat Q out being rejected to the environment. The equation of Q out is equal to HA times T junction minus T ambient.
So, what law of thermodynamics involve? The functioning of watch primarily involves the second law of thermodynamics, which deals with entropy and the direction of spontaneous processes. So, the second law of thermodynamics states that the total entropy of an isolated system can never decrease over time. It remains constant if all processes are reversible, and it increases if any process is irreversible. In simple terms, this law dictates that the natural processes tend to move towards a state of greater disorder or randomness. Other law of thermodynamics which involve is first law of thermodynamics, law of energy conservations. So the energy stored in the battery or by winding the watch is conserved and transformed into the mechanical energy that powers the watch. This law ensures that the total energy within the watch system and its environment remain constant, but its form changes. Next will be the law of thermodynamics. As the watch operates at normal temperatures, the effects of the third law, which concern the behavior of system as they approach absolute zero temperature, are not significant in this context. And lastly is zeroth law of thermodynamics. So this law, which concerns thermal equilibrium, is not directly relevant to the operation of a watch, but ensures that all parts of the watch remain at a uniform temperature, contributing to its stable operations. Next will be efficiency and performance. Efficiency in the context of a watch refers to how well it converts the stored energy from a battery or mechanical winding into precise, accurate timekeeping with minimal energy loss. So we have energy source, that electrical energy from a battery, energy conversion, quartz crystal oscillators when convert electrical energy into precise oscillations, energy losses that minimal compared to mechanical watch, primarily due to electrical resistance and minor mechanical frictions. And also improving efficiency, which involve low power circuits that modern quartz watch are used, highly efficient electric circuits to minimize battery drain, and optimized oscillator that are cut and treated to oscillate with the minimal energy loss. As in performance involves the accuracy, reliability, and durability of the watch. For the first point will be accuracy, which involve factor influencing accuracy. For temperature stability, quartz oscillation frequency can vary slightly with the temperature. And also improving accuracy as in thermal compensations. Advanced quartz watches include the circuits that adjust for temperature variations. Second is about the reliability, which is generally more reliable with fewer moving parts and longer intervals between maintenance. And last but not least will be durability, that for as in improving durability, use of scratch resistant materials like sulfur crystal and robust casing. Next will be suggestions to improve. For my first point will be energy efficiency. As in low power circuits, we should design circuits that consume less power, which extending battery life. Next will be solar power, which integrates solar cells to supplement battery power, reducing the needs for frequent battery replacements. Secondly is accuracy improvements, as in thermal compensation state, which includes that adjusts the frequency of the quartz oscillator to compensate for temperature variations, and also high precision oscillator, or use the higher frequency oscillators, for example like 32,700 and 68 Hz or higher for more accurate timekeeping. Third will be durability. So using sapphire crystal for the watch face to resist scratches, and also by using tough case material that utilize materials like as in titanium or high-grade stainless steel for increased durability and also corrosion resistance. Moving on, next point, which is the enhanced functionality. For smart features, integrate smart features such as Bluetooth connectivity, fitness tracking, and notifications without significantly compromising battery life. Next, advanced sensors that add sensors like GPS, altimeter, and barometer for additional functionality in sports and adventure watches. 5 is maintenance and user experience. So use batteries with longer lifespan such as lithium ion to reduce the frequency of replacements, and also user-friendly interface that ensure the interface of intuitive and easy to use with clear displays and simple controls. Lastly is aesthetic and design, which is customizable dials that allow for customizable watch faces, either through changeable parts or digital display in hybrid watches. And last but not least is ergonomic design that focus on ergonomic design that are comfortable for a long-term wear. In conclusions, the operation of a watch is intricately linked to the principles of the second law of thermodynamics. This law is stated that the total entropy of an isolated system can never be increased, highlights the natural tendency towards energy dissipation of and inefficiency within the watch mechanisms. As an example, mechanical watches, through the movement of gear and springs, lose energy primarily as heat due to frictions, while quartz watches convert electrical energy from the batteries into precise oscillations with minimal loss. Both types of watches, despite their sophisticated engineering, cannot escape the inherent inefficiencies dictated by the second law. These uses require external energy input, whether from winding or battery replacement, to maintain order and accurate timekeeping, illustrating how thermodynamics principles govern even the most refined and precise devices. Thank you.